Hello everybody. Welcome back to the channel. Today, I've got something interesting, especially if you're working with older hardware or setting up lightweight monitoring systems. We're going to install and compile Zabbix 7.0 from source on a 32-bit machine using a fully automated bash script that I wrote. This is perfect for turning old, underused computers like this Atom-based industrial PC into a fully functional monitoring server. Let's dive in. So, why this project? A while ago, I needed a quick and simple way to monitor a small office network. But I didn't want to waste newer hardware. I had this old industrial PC lying around, 32-bit CPU, limited resources, and I thought, let's make it useful again. Zabbix is a great open source monitoring solution, but compiling it on a 32-bit machine is not exactly plug and play. So I automated the process. The whole setup and build takes around 1 hour and 40 minutes in real time, but don't worry, I'll show you the highlights, and the full script is available on GitHub. GitHub script: https://github.com/sznetwork/install_scripts. Here's the script we'll be using today: compile_Zabbix 7.0.sh. You can download it directly using this command. Book at https://github.com/network/install_script/raw/ref/head/main/check/compile_Zabbix 7.0.sh. Next command: make file executable. Mod +X compile_Zabbix 7.0.sh. And then just run it. /compile_Zabbix 7.0.sh. Let's go step by step through what it actually does. First off, the script updates and upgrades the system. Then, it creates a dedicated Zabbix user and group for better system separation and security. It also switches the repository to Debian unstable to get all the most recent package versions that Zabbix 7.0 depends on. Install command output montage here. This step alone can take a few minutes, especially on slower hardware. Next, we install all the necessary dependencies. That includes development tools like Build Essential, libraries for SNMP, MySQL, LDAP, SSH2, OpenSSL, and all the PHP modules required for the frontend. This part ensures we have everything we need to build and run Zabbix correctly. Now we download the Zabbix source code from the official site. Unpack it, enter the directory, and then configure the build. Show output of /configure**. Then we run make install. This is the longest part. Compilation can take well over an hour on a low-powered machine. So grab some coffee or two. Setting up MySQL/MariaDB. Once compilation finishes, we install MariaDB and secure the installation. The script will ask you to create a MySQL password for the Zabbix user and to provide the root MySQL password. Once you enter those, it automatically creates the database and user, and loads all the necessary tables. Note, the script avoids using special characters in passwords to prevent parsing issues. Importing the database schema. After the database is ready, the script imports the schema, images, and base data into MySQL. Each step is shown and clearly labeled, so you know what's happening at all times. Configuring Zabbix server. The script now modifies the Zabbix server config file to add the database password and a couple of other options, like allowing unsupported DB versions, which may be useful for 32-bit systems. It also creates custom system service files for both the Zabbix server and agent so they start automatically on boot. LAMP stack and web UI setup. Now we configure the front-end. The script installs Apache and all the PHP packages, copies the Zabbix UI to /var/www/html, and adjusts php.ini settings for performance. We bump up memory limits, max upload size, and execution time to accommodate Zabbix's needs. Clean up and reboot. Finally, We clean up unused packages with apt auto remove, restart Apache, and optionally reboot the system. After reboot, the Zabbix server and agent will start automatically. Browser shows Zabbix login page *. You can now finish the Zabbix setup in your browser by visiting http://. So that's it. We turned an old 32-bit PC into a fully working Zabbix 7.0 monitoring system with just one script. This is a great example of how old hardware can still serve important roles if set up right. The script will continue to be updated, and I welcome feedback or pull requests on GitHub. If you found this helpful, give it a like, leave a comment, or subscribe for more DIY server builds and Linux automation tips. Thanks for watching, and see you next time.